Okay, good morning. Good morning. Um, some people are not in yet, but let's still start on time and uh, start. Okay. Um, this is the syllabus, right? So up to this point of time, we actually have spent the last two sessions, one for data manipulation package deployer, right? It actually, this is the tool set that help you manipulate the data, right? Aggregate the data, analysis the data. And then we will have our, last week we're talking about ggplot, right? Which is actually a data visualization tool, right? Okay. Why do we want to do visualization in business analysis? Because we want to compare, right? We want to compare between area. We want to compare between product category. We want to compare amongst customer and customer group, right? We want to compare the characteristics of different customer group so that we can determine if we want to set a focus on customer, right? We need to compare the characteristic among all of the customer. Right? If we want to, if we wanted to like set a focus on some product category, right? We want to compare the characteristic of product category so we can make the decision. Right? So this data manipulation and data visualization help us to understand our business condition, right? It helps us to have a holistic understanding of our business situation, to understand where our revenue, where our profit come from, right? So we can set our strategy, right? Set the direction of our next step. To be specific, we want to say in each product group, product category, in each customer group, right? We want to do the improvement, right? And because we know the current status of all of this product category and all of this product group and customer group, so we can set the goal of improvement, right? I want to improve my revenue for 10%. I want to improve my profit for 5%. So before you can choose your focus, before you can set your business objective, you need to know the status of your condition. And that's why we explore the data and visualize the data to help us do the communication, right? Okay? Right, that's basically, yes.
Professor, so in statistics, like most of us are doing it right now this semester. So they have hypotheses testing and statistics. So is it possible to use R to test a hypothesis?
Yes, you can do that. Well, actually, this quantitative method there are a lot of different quantitative methods, right? Mostly in our course, we are doing descriptive statistics and we are doing prediction, right? Okay, and hypothesis testing is sort of what we call inferential statistics. Okay, you have a hypothesis and you want to use some method to test the validity of that hypothesis. That is called inferential statistics. And actually it's out of the scope of this course, right? In this course, we are more practical. We are not talking about the theory. We are not going to like raise some theory and try to test the validity of the theory. basically we are using the data to do prediction. We are using data manipulation skill to help us understand the business, right? So we can set the strategy, we can set the operation tactics, and then so we are more operational than theoretical. So we can do that in R, but in this course we are actually doing in the different aspect.
But usually, like in businesses, let's say if a product is not selling, let's say like right now the iPhone 14 Plus, Apple said that they're reducing the manufacturing of iPhone 14 Plus, and they want to find out the reason why. So do they use data analysis to do that, to test?
Okay, this is the other type of purpose for using analysis. Okay, so if you want to, the question that you are asking is what we call diagnostics, right? You want to know the causality, right? Okay, now usually inferential statistic only help you to like find out the relationship between variables, right? Theory is basically a theoretical postulation about the relation among variables, okay? But if you want to really do a diagnosis, you want to do the prescriptive, to do the prescription, then you need to know the causality, right? So for causality type of method, usually you will need to do experiment. Right? You cannot only use the observational data, but because if you are only using the observational data, you can find out the relationship between variables, but it's very difficult to establish the causality between them, among them, I should say. So inferential is one thing, diagnostics is the other things, and that is more theoretical than practical, right? So you will have some other courses help you do that. For example, you will learn a thing called research method. Do you have a course like that?
Yeah.
So in the course of research method, will teach you how to do inference, will teach you how to do diagnosis. That's not the purpose of our course. In our course, we are using R to do prediction. Okay? Given data, I want to predict the future. I want to predict the demand. I want to predict the for each of the customer. I want to predict what is the probability that he will repurchase, right? And what is the expected revenue contribution that this customer will contribute in the next month, things like that. So what we are doing here is description and prediction. We are not doing inference. We are not doing diagnosis, okay, in our course. Very good question, very good question, okay. And that actually differentiate our course from the traditional research method. Right? Research method is good, okay. It helps you to do the theoretical type of things, but it tends to be too narrow, right? Well, for manager today, sometimes you only want to do the prediction, right? You don't really have the time to dig very deep into to find the root cause, to find the. Sometimes you want to do that, but for most of the time you are doing description and doing prediction. That is the focus of our course. Got it? Okay. Okay. So, any more question about the course up to this point of time? This is the syllabus, right? So this week we are going to do some data exploration. Basically, using what we have learned so far, using R as a tool to help us explore the data so we can do strategic planning, right? That is the thing that I want to do today. And next week we will teach some of the more advanced method, okay, for data exploration. And the week of November the 7th is your midterm presentation, and each team you prepare a presentation of 12 minutes, okay, by using all of the skill we have learned so far, okay. So today let's go to the unit page. Today we are doing from exploration to strategy, okay? And actually we already have some exploratory toolbox, right? Data exploration toolbox. We have data manipulation, data visualization, right? And this advanced method, we have not teach this yet, okay? We will teach that next week. So today we are using like we are using the Tafan data set, and we have I will actually just walk you through all of this 4 notebook, okay? So today, if you go to today's shared drive folder, the Tafan .zip, you already have it, okay? So in your notebook, you should already have a Tafan data folder, right? So and within this folder, you should have 1, 2, 3, 4 notebook, okay? So this is the thing that I would like to walk you through, kind of like combine all of the methods that we have learned so far to do exploration, and try to use this exploration to do some strategic planning, okay? Yeah, so this is the game plan today, okay? In the beginning of the course, we have see this picture, right? Okay, so today when we are talking about business analytics, actually we are talking about a data processing pipeline, okay? Kind of like a assembly line, right? So you collect data and you use tool, and basically you will use a lot of tool, and you will kind of like using data as the material, right? And using this tool as the station in the assembly line, right? So you do exploration, analysis, you do prediction, you do simulation, optimization, right? And you need to, based on the result of all of this data analysis, you do planning, you do presentation, okay? Now along the way, it's not only, you are not only applying this programming and data manipulation, data analysis technique. You need to combine this data analysis technique with your managerial knowledge, okay? Because this is the purpose, right? This is the purpose, and this is the tool, right? We are using this tool for this purpose. So these two things need to combine together, right? And that's why we do not have time to go into the detail about diagnosis, to go into the detail about detailed inferential statistics, okay? We basically using data analysis to help us do exploration and prediction. That is how we use data in our course, okay? Okay, so basically, this is how we, if we simplify this slide, right, a little bit. Now, this is the purpose, right? As a manager, first of all, you want to set the strategy, right? You want to set your focus, you want to set your goal. specifically in the case of Tafang, right? You might want to set an area as your focus, right? And why do you want to? For example, I want to set zip code 221 as our as the focus of our campaign for next quarter, right? Why? Why do you want to choose that? Because you compare, if you compare the revenue and profit area by area, you can see that maybe 221 is one of the, right? Maybe it is contributing most of your profit, right? Maybe it's contributing most of your revenue, but its profit is no good, right? So you want to focus on that, try to solve the problem, right? So before you can choose your focus and set your goal, you need to explore the data, right? You need to have a holistic understanding of your business condition. And then you want to compare the group characteristics so you can set the focus, right? And because you know the current situation, so you can set the goal for improvement, right? So that's why we want to do data exploration, right? Okay, you do the exploration, you have a holistic, you have the group situation, so you can set the strategy, right? Now, strategy is nothing but choice, right? What do we mean by strategy? It means our choice, right? What is your marketing strategy? Well, specifically, we are talking about we want to spend most of our marketing resource on some customer, on some area, on some product category. You are choosing them, right? And after you choose them, you set the goal for improvement, right? So this is strategy, and we are using data to justify our choice, okay? Or I should say that in the other way, you are using the result of your analysis to formulate your strategy, okay? And that is what we are going to do in our midterm, okay? We have learned a lot of data analysis technique, right? Next week we'll teach more data exploration technique, more advanced data exploration technique. But using this technique will help you to understand your data situation and set your strategy. And that is what we want to cover in the first half of our semester, right? And in the second half of the semester, we are going into kind of operational type of thing. The strategy will not realize itself, right? Say I want to, if I have a strategy that I want to raise the profit of the age group 35 from 2 million to 2.5 million. Just for example, okay. Say I have this goal, right? But this goal will not realize itself. If I do not do some campaign, that will not happen automatically, isn't it? Right? So if you want to do a campaign, you need to determine a lot of things, right? Okay? You have different type of campaign, right? I can organize some event. I can do some advertisement. I can send out some price discount, right? I can send some coupon, right? And for example, if I want to send coupon, then what kind of coupon should I set, right? And who should I send the coupon, right? How much money? What is the amount of the coupon, right? And if I send this coupon to this group of people, I would like to evaluate what is my cost, and also what is the effectiveness, what is the effect of this coupon in terms of purchase probability, in terms of purchasing amount, right? So I can justify that the budget that I spend on my campaign operation have a good enough return on investment, right? Isn't it? Right? So in order to do that, in order to design your campaign and design your campaign instrument, okay, and choose your target audience, right, and then estimate the expected value, estimate the expected return, that when you use this instrument on this target, you want to have some forecast, want to have some expected value about its probable outcome, isn't it, right? In order to do that, you need to do prediction. We need to do modeling, okay? Up to this point of time, we don't do model yet, right? But starting from after our midterm, we will start to do this, okay? We can do some prediction, do simulation, okay? By doing prediction and simulation, actually we can design instrument, choose target, and estimate effect. That is what we want to do in the next half of this course, okay? Actually, in order to do that, only prediction and simulation is not enough. Usually you need to have some assumption, okay? And where does this assumption come from? Basically from your managerial knowledge, okay? And this managerial knowledge is not only good for operational reason, it's also good, it's also necessary when you are doing strategic planning, isn't it? Right? So the tool that we are using, that we are learning in this course, would not can only be helpful when you apply them with your managerial knowledge, with your business mindset, right? So you need to combine them together before you can. So teamwork is very important, okay? Teamwork is very important. I really encourage you to get together for your midterm, for your team assignment week after week, okay? Okay, so we already say that, right? So this week we are going to do EDA, exploratory data analysis, okay? The reason that we want to do EDA is because we want to do strategic planning, okay? And so EDA is nothing but comparison, right? Okay? And when you do the comparison, then you can choose your target, right? And when we are doing model, that is for the second half of the course, okay? Model is for prediction, okay? And EDA is for comparison, for exploration. You do exploration for strategy, and you do prediction for operational design, okay? Now, as I say, strategy is nothing but choice, right? So you compare your customer, compare your product, compare your channel to set the focus and goal, okay? And that is what we want to do in your midterm, okay? And this is what you want to do. This is what we will do in our final, okay? Got it? Any question? Question? Okay. If no question, let's start to do. Let's look into the data first, right? usually that would be a lot easier to understand the concept. If I'm only talking about concept, it's really like not very useful, I think. So if you look into this Tafang folder, you will see 4 notebook, right? And the first notebook is actually for data preparation, right? You still remember this one? Actually, in this notebook, this is our raw data, right? The data we have is actually very simple. We only have like 817,000 order item, right? Do you still remember the raw data? The raw data is like data items, right? Item by item by item, right? So in this Z data set, let's load the data and see what we have now. Let's start from exploration, right? Because this preparation, we already do that. Okay, so so we have 3 data frame, right? Okay, and in this Z data frame, this is the product item, right? And this is the transaction, right? And this is customer, right? This A data frame, we have 3, 2, 2, 4, 1 customer, which means that every record, every row in this data frame is a customer. Okay, so in this data set, we see 32,000 customer, right? And every customer are different, right? They have different characteristics. See that, right? And how about this one? Each row in this X data frame represent what?
Transaction.
An order, right? A transaction, right? What is this?
The date and time of transaction.
The Z is actually the item within the order, right? When you go to a grocery store, usually you will buy separate items in each transaction, right? So every customer will have some transaction, right? And every transaction, every order will have some item, right? This is the data. Now, so if we have all of this data here, actually we can count the number of customers, count the number of transactions, count the number of items. We can read the data here actually, right? And usually, if we want to, because we have like 32,000 customers, right? So if we want to look into the characteristic of each customer, it would be too messy, right? You cannot like see them, right? So for data exploration, usually we start from one single variable at a time, okay? For example, if I want to understand my customer, first of all, I want to see their age group distribution. I want to see their area distribution, okay? This is called distribution because it tells us the value, how the value of a variable is distributed, okay? This is called distribution of age group, right? In this data frame, this column, how many value do we have in this column?
The same as the number of customers?
Yeah. So it's like 32,000, right? So if I give you like 32,000 number, you cannot see anything, right? So first thing you want to understand is like you want to count, right? You count the different value within area. You count the different value within age, right? So you can see, if you want to understand your customer, right? In one way, we are talking about we want to know the distribution of each of this variable, isn't it? Right? Age and area, they are categorical variable, isn't it? Right? So for this categorical variable, usually we want to see their distribution by bar plot, right? You already learned that, isn't it? Okay? So the bar plot actually for each of the unique value in area, it counts the number, right? And visualize the number. So you can have an understanding of the age distribution of your customer, the area of your customer, where your customer comes from, right? Now, but sometimes you want to like understand not only the one variable, right? When we are doing exploration, the difficult thing is actually you want to see the relationship among the variables, okay? That's where exploration, that's where the complexity kick in, okay? Now, seeing one variable at a time is easy, okay? Right? You just use bar plot, you just use histogram if you are looking at the continuous variable, right? But sorry. But as I said, age is a categorical variable, and area is the other categorical variable, right? And this chart is what we call mosaic plot. This plot is called mosaic plot. It basically helps us to see the joint distribution of age and area. Joint distribution, okay? Still, it counts the numbers of each of the age and area combination, okay? See, in this direction they are age, right? And in this direction they are area, right? So each of this mosaic, each of this rectangular actually represent area and age combination. For example, this one, okay? It represents Z110 and age 39. See that? Okay. So this visualization actually use the area of rectangular, the size of the rectangular to represent the number of customer of area and age combination. See that? Okay. So the box, the size of the box is actually the count. Okay. Now how about the number? How about the color? The color actually gives you the relative comparison of the cell. Okay. Basically, the red color, it means that citing this, I'm using this row as the example. Okay. This row is for Z115. Okay. So each of this box represent within Z115 the size of each of the age group, right? And the red color, it means that compared to the entire population, okay, the customer live in Z11Y, their proportion of A34 and A39 is significantly lower than the entire population. Okay? See, actually, these two bugs is actually larger than these two, right? But the reason that I say that they are significantly lower, I mean that compared to the entire population, okay? I mean compared to this we call marginal distribution. Okay. See, this is the if I do not consider area, right? This is the overall distribution, right? This is the overall distribution of the age group, okay? And the reason that this two box is red, it indicates that in Z115, their age group distribution of 34 and 39 is lower than the group population. See that? You get the point? Okay. So relatively, in Z115, the distribution of A34 and 39, or I should say the proportion of A34 and 39 in Z115 is lower than the entire population, right? In compared to the, and this is important, right? With this joint distribution, what do we want to learn? We want to learn that we have learned that in different area, our customer, the age distribution of each area are different, right? For Z115, these two age group has a lower proportion, okay? And the elderly people, they are more older customer in Z115, right? In compare to the entire area, okay?
But if they're more, then why is the width of the rectangle less than the red one? Like
well, actually, the question is that, for example, this one is actually like narrower than the red one, right? But why I say that it's significantly larger, because we are comparing this age distribution of Z115 with this one, right? The A39 and A44, well, in general, I mean, if we do not consider area, they are larger, right? They are larger already. So this is the base of comparison, right? When we are using this joint distribution, we are actually compare the age distribution of each area with this one, okay? And because these three age group are larger, right, in general. So even though this is large, okay, but compared to the other area, it's still smaller, right? It's still less. The ratio is still smaller, right? You get my point? So this relative comparison, okay, but this relative comparison gives us different characteristic of different area, right? With this graph, with this joint distribution, we can tell that, we can tell the difference of age combination, of age distribution across area. See? And when we do that, we actually, when we want to compare, we need to have we need to have a baseline, right, for our comparison, right? So the joint distribution, the base for comparison is actually this one, right? That is why the box is wider here, right? But they are actually red. Because they are they are doing the comparison in this direction, right? You see that? Okay. So Mosaic Plus is actually a very useful tool, right? In this case, it helps you to understand. It helps you to understand the different. You help you to understand the edge distribution are different across different area, right? Okay. That's for better continuity. Let's go to see this one. See, I already write a function for you, right? So for some reason, if I want to see, this is the product category, right? And this is the age group, right? So for each of the product category, I can see that some, for example, this product category, A44, you can see the preference of age group and product category, isn't it? See that? Okay. The joint distribution can help us to find the difference across different group, right? This mosaic plot actually show us that right, for every different category, the age group distribution, right? Okay. The trick is actually, let's take a look at here, right? The top 20, what is top 20 is actually, this is actually the top 20 product category, okay? Because you have like several thousand product category, right? If you want to see like 20,000, you can see nothing, right? So if you only consider this top 20 category, and you want to see that what age group preferred which category, right? You can do this type of analysis, okay? Oh. See, okay? Actually, a better way to do this is to put edge here and product category in this direction. It'll be a lot easier. Let me show you. Actually, if I change the direction. Now I have, right? Now I have age group, right? And I have product category in this direction. See that? So if I want to know that relatively, what are the product category that A39 prefer? This is two product category that A39 prefer, right? And for A44, they are different, right? They prefer this one, and this one, right? Compare with the other age group, right? I can say that A39 prefer this one, and they don't like this one, isn't it? See? So you can see the difference preference of different age group, right? By using mosaic plot. Okay. I don't really have time to explain the mathematical detail about this one. If you take the course of statistics and probability, there's a test called chi-square test, right? This is basically chi-square test, okay? And when I say that they are significantly larger, we are actually talking about by using chi-square testing, they are significantly larger, okay? Statistically, they are larger. But when I say statistically larger, well, it's very difficult to connect it with the practical usage, right? Isn't it? Right? So in our course, I would like to try to connect the result of analysis to your business practice. Okay. So this is practically important, isn't it? This chart. See that? See if I can. Now, this part is important because now I can see the different product category preference of different age group. I can see that, right? Okay. And so I can tell that it looks like that for younger people, they don't like this product category, right? But for the older people, they like this product category. See? Okay. So when you put two categorical variable together, you can actually use mosaic plot to do a very useful visualization. But before you want to do that, you should be careful, right? For age, because they are only like 10 age group, right? So it's fine. But for product category, they are how many product category do we have? It's not here. 2,000 and something, right? So if you have like 2,000 product category show in one graph, you will see nothing, right? So basically you need to do some filtering, right? That's why we like kind of like filled out the top 20 product category, right? And you do an indexing here. See that, right? So and this MOSA function are already built for you, right? So try to use this to explore the relationship amongst categorical variables, right? So you can see see some information, see some useful information when you're doing the strategic planning. See that? Okay, let's take a 10 minutes break and then we'll go back, okay?